Alright, so for partial derivative, from the normal expression we know y is equal to x to the power n, the y over dx is equal to nx n minus 1. You multiply the base by the power, then minus 1 from the power. That's how you solve for derivative. So you're given the function z is equal to f of x comma y. So z is a function of two variables, x and y, is what they are saying. So now you call this partial z over partial x. You see the d is not like normal d. Partial z over partial x is called first partial derivative of z with respect to x, and then you have partial z over partial y. It's called first partial derivative of z with respect to y. Now let's see how we use this in equation. Now it says let f of x comma y be equal to x to the power 3y minus xy square. Find partial f over partial x comma partial f over partial y. Now we use partial derivatives because you're giving multiple variables. You get, is no longer z is just a function of x. Here z is a function of x and a function of y. You understand? So z is expressed in terms of x and y, is what you're trying to see. All right, solution. So f of x comma y is equal to x to the power 3y minus x y square. Partial f over partial x is equal to, you're differentiating this entire function just with respect to x. So you just differentiate the x and you leave the y variable. So that's what I did here. Differentiate this one from our first form for derivative is dy over dx is equal to nx n raised to power n minus 1. So it's the same thing you do here. 3 bracket x to the power 3 minus 1. You leave the y variable minus 1 bracket x to the power 1 minus 1 y square, which is equal to 3 minus 1 is 2. So 3x to the power 2y minus 1 bracket 1 minus 1 0. You know, laws of indices, anything raised to power 0 is 1. So 1 times 1 is 1. So your final answer is 3x square y minus y square. Partial f over partial y is equal to x to the power 3 times 1 bracket y raised to power 1 minus 1 rather minus x times 2 brackets y raised to power 2 minus 1. We are just differentiating the y variables now. So your final answer, having gone through the steps, is x to the power 3 minus 2xy. Now the second question, a funny question. Given z is equal to x square y minus x sine xy, you're asked to find partial z over partial x and partial z over partial y. Solution: z is equal to x square y minus x sine xy. Now we are differentiating partially with respect to x. So you have 2xy minus, when you look at this stuff, is there's a product multiplication going on between the x here and the x here. So you're having x times sine xy. You know how product rule works from your this in elementary calculus. You know how product rule works. When I was solving, then I was like, oh shit, this stuff is here. But then it's not an issue. So you know product rule is if you're giving um how did they put that stuff again? D over dx of uv is now going to be u times dv over dx plus v times du over dx. Yes, that's it. You have to find the differentiation of uv with respect to x is going to be u times v, or the one my teacher taught me, the one I normally use is v times du over dx plus u times dv over dx. Now this thing here is x sine xy, x sine xy. I don't know, I guess I will solve this while recording. You have x sine xy. We say let u be equals to x, let v be equals to sine xy. Du over dx is equal to 1. dv over dx is equal to, you're having a function of a function. The independent variable is xy, the dependent variable is sine. So now when I want to differentiate this, I first differentiate the dependent variable, since it's the easier one as you just look at it. Then I then differentiate the independent variable. Xy can stand on its own, but sine cannot stand on its own. You can't just say find sine. You need to check sine what. You can give xy. Xy is a variable. Both of them are somehow, but then what I'm saying is that xy is the independent variable and sine is the dependent variable. So dv over dx is differentiate sine xy is going to be cos xy times differentiate xy with respect to x is going to be y. So this is going to be y cos xy. So now when we use this thing, d over dx of x sine xy, I said I'm using v du over dx with u dv over dx. So our v is sine xy, v du over dx is 1 plus our u is x, dv over dx is y cos xy. So is equal to sine xy plus xy cos xy. Yeah, that's it. That's what I did here. So you have differentiating this, you have v times du over dx 1 plus u times dv over dx. Differentiate sine xy is give you cos xy, then differentiate xy with respect to x is give you y. When you open the brackets, this is what you have. Then let's differentiate partially with respect to y. You have x squared minus, there's no products here. I didn't even had a y, okay, then we would have applied product. So this x is kind of like a constant, so you just have x as a constant bracket. Differentiate this stuff with respect to y. You differentiate sine xy, you have cos xy times differentiate xy with respect to y, you have x. When you open the bracket, you have x squared minus x squared cos xy. You collect or you factorize it, you have x squared bracket 1 minus cos xy. Alright, the third question, you're asked to find z. Okay, you're giving z is equals to x squared plus y squared minus 2axy. Here, a is a constant. A is a constant. So you're asked to show partial square z over partial x partial y is equals to partial square z over partial y partial x. Solution, you're giving your function, you state down your function. Z is equals to x squared plus y squared minus 2axy. Partial z over partial x is 2x minus 2ay. Differentiate with respect to x, the x is going to go out. Partial z over partial y, there's no y here, so this is 0. This is going to be 2y minus the y goes out here. Differentiating with respect to y, and you have 2ax. Now partial square z over partial x partial y is equals to partial d over partial x all over partial z divided by partial y. Okay, this is how I used to express it. So you're giving, I don't know, can we just call it the square z, but you should see the sign and know it's partial. So the square z over dx dy is equal to d over dx bracket dz over dy. So now your dz over dy, this is our dz over dy. We are differentiating it with respect to x again. So there's no x here, so this is 0. This x is not going to go out, so you're left with minus 2a. And then d square z over dy dx is equal to d over dy bracket dz dx. So what you're giving for dz dx is this. Differentiate this again with respect to y. Differentiate this with respect to y. There's no y here, so this is going to be 0. You have minus 2a. Your y here is also going to become 1. It's going to go out when you differentiate it, so you're left with minus 2a. So at the end of the day, you find out that the square z over the x dy is equal to minus 2a, which is equal to the square z over the y dx. So we've shown that they are equal to each other. So at all points in time, take note, at all points in time, the square z over the x dy is equal to the square z over the y dx. Alright, that will be it for now.